Before we dive into today's adventure through the annals of history, it turns out that only a tiny fraction of you watching are actually subscribed. Subscribing might seem like just another click in the digital ocean, but it's a huge boost for us here. It helps the channel grow, reach more history enthusiasts like yourselves, and keeps us uncovering the fascinating stories you love. These days, most viewers aren't using the subscription feature, but if you enjoy our content, hitting that subscribe button really makes a difference. It supports the channel in a big way and helps us bring even more intriguing tales from the past into the spotlight. So if you haven't already, consider subscribing. It's a small action that contributes to a larger journey. And as always, thank you for being here, and now, let's get into the story. Back in 1936, the Reichsluftfahrtministerium, or the RLM for short, was on the lookout for something ambitious, an engine that could churn out 1,800 horsepower. Why? For the next fleet of bomber aircraft that would redefine aerial warfare. It was a tall order, signaling a leap into uncharted territories of aviation technology. At the helm of this quest was Otto Mader from Junkers Flugzeugen Motorwerk AG in Dessau. Junkers was a big deal in the aviation world, and Mader, weighing his options, delved into the possibilities of V and H configurations for this powerhouse engine. Each had its perks and pitfalls, but nothing quite fit the bill. Enter Ferdinand Brandner, the new guy at Junkers with a knack for engines and railways. When Mader brought him into the loop, Brandner didn't just see a challenge, he saw an opportunity to go above and beyond. The goal? An engine that would not only meet the RLM's ask, but push the envelope to 2,000 horsepower. And so, with Brandner at the drawing board, the P2001 project kicked off, eventually making its pitch to the RLM in December 1936. By May 1937, the RLM was on board, commissioning a prototype that would, a year later, be dubbed the Junkers Jumo 222. Brandner's blueprint came to life in June 1937, setting the stage for what was to power the beefed-up version of the Junkers Ju-88 bomber, initially tagged the EF-73 and later known as the Ju-288. The 222 was a liquid-cooled inline radial engine that threw the rulebook out the window with its hexagonal design. Imagine 6 cylinder banks, each with 4 cylinders, fanning out radially around the crankcase like spokes on a wheel, but angled at 60 degrees. This setup wasn't just for show, it was a masterclass in engineering, making the Jumo 222 one of the few engines to boast a hexagonal layout. It joined an exclusive club that included names like the Curtiss H-1640 Chieftain and the Wright H-2120, among others. The engine's heart, a 2-piece aluminum crankcase, was split horizontally, with an interesting arrangement. The top 4 banks sat on the upper half and the bottom 2 on the lower. They were held together by a series of studs, including 4 long ones running from the center main bearing, a testament to the engine's robust design. At the core of all of it was the crankshaft, a 1-piece wonder supported by 5 main bearings in the upper crankcase half. The main bearings themselves were a fortress, secured by vertical studs and 1 exceptionally long stud that went through the entire crankcase, ensuring everything stayed exactly where it was supposed to be. The connecting rods were a work of art, with a master rod on each of the crankshaft's 4 throws, accompanied by 5 articulating rods. This intricate dance of metal was secured by bolts, with a specific arrangement for the master connecting rods that evolved over the engine's development. And then there were the pistons, short and stout with a quartet of rings ensuring compression and oil were managed just right, all working together to achieve a compression ratio of 6.5 to 1. The Junkers Jumo 222's design intricacies showcase a blend of innovative engineering and practical solutions. Steel cylinder barrels meticulously installed through the crankcase and sealed with rubber rings underscore the engine's reliability and attention to detail. These barrels connected to the cylinder head via a flange and 4 long studs, creating a precise seal with a tapered aluminum ring ensuring optimal combustion chamber integrity. The combustion chamber itself was designed with efficiency in mind, adopting a wedge shape that strategically positioned the exhaust valve on the shorter side to maximize airflow and combustion efficiency. This setup was complemented by 2 intake valves and a sodium-cooled exhaust valve for each cylinder, highlighting the engine's advanced cooling strategies. Fuel delivery was precisely managed by injectors located between the intake valves, with spark plugs optimally positioned to ensure consistent ignition. The valve operation was smoothly coordinated by a single overhead camshaft for each cylinder bank, driven by a series of spur gears. The gear reduction unit attached to the front of the crankcase enabled the propeller to operate efficiently at varying speeds depending on the model. The supercharging system was a critical component, featuring a large diameter impeller that operated across 2 speeds, significantly enhancing the engine's performance by providing substantial boost for takeoff. The supercharged air was then evenly distributed to the cylinders through a meticulously designed manifold system, ensuring optimal engine operation. Exhaust management and engine mounting were thoughtfully integrated into the design, with individual exhaust stacks and mounting pads strategically placed to facilitate efficient operation and installation. The inclusion of an inertial starter and coolant pump further demonstrated the Jumo 222's blend of performance and practicality. The Jumo 222's design intricately arranged its cylinder banks radially around the crankcase, starting with bank 1 at the 3 o'clock position and moving counterclockwise, with each bank's cylinders numbered from front to back. This layout wasn't just for mechanical efficiency, it played a critical role in the engine's operation, especially considering the ignition system. Each upper cylinder bank had a magneto attached, responsible for firing all cylinders across 3 banks. This setup, however, meant that a single magneto failure could incapacitate half the engine, a stark reminder of the fine line between innovation and operational risk. The engine's development saw changes even in the firing order, a detail that underscores the ongoing quest for optimization and performance enhancement. The bore and stroke measurements laid the foundation for an engine that was both powerful and capable of remarkable feats. Initially, the Jumo 222A/B1 models promised 2,000 horsepower at 3,200 RPM, but relentless development efforts soon pushed these figures higher, achieving a takeoff power of 2,500 horsepower and maintaining formidable power at high altitudes. Climbing and cruising powers were finely tuned for performance, with specific outputs detailed for operation at sea level and at altitude, showcasing the engine's versatility and reliability across differing flight conditions. Moreover, fuel consumption rates were meticulously calculated, reflecting the engineering dedication to efficiency and sustainability even in the face of demanding operational requirements. The physical dimensions and weight of the Jumo 222 model highlight the substantial nature of this engine, both in its promise and its presence within the aircraft it powered. With a diameter just shy of 4 feet and a length of over 7 feet, the Jumo 222 was a behemoth by any standard. The engine's development swiftly progressed from single-cylinder tests in early 1938 to a complete 6-cylinder row by mid-year. By April 1939, a full 222A/B1 engine roared to life, impressively reaching 3,000 RPM without a hitch. Junkers, seizing the moment, proposed the Jumo 222-powered EF-73 for the RLM's consideration, envisioning it as the next evolution of the Ju-88 bomber. The EF-74, a similar design but with the Jumo 224 engines, highlighted the era's experimental fervor, with manufacturers and the RLM alike dreaming of faster, more powerful bombers. This ambition crystallized in July 1939 with the Bomber B specification, demanding an aircraft capable of significant bomb loads, range, and speed, a challenge tailor-made for the Jumo 222. When the RLM made a call for possible engine alternatives, Junkers was not deterred, and the Ju-288, powered by the Jumo 222, emerged as a frontrunner among proposals that included designs from Arado, Focke-Wulf, Dornier, and Henschel. The competition was fierce, with BMW and Daimler-Benz also throwing their hats into the ring with their engine designs. Yet the 222, powered by the Ju-288, stood out, selected for production alongside prototypes of its rivals. The journey to 2,000 horsepower was fraught with challenges, from lubrication issues to connecting rod reliability, but by mid-1940, the revised Jumo 222A/B1 was up and running. Test flights began with a modified Ju-52, and although the Ju-288's first flight relied on the BMW 801 radial engines due to timing, the path was set for the 222 to take its place in aviation history. Junkers' response to this critical moment was the formation of the Automator Work, a dedicated hub for the advancement of engine technology in Dessau. Here, the Jumo 222 and the pioneering turbojet Jumo 004 received focused attention, marking a pivotal phase in their evolution. By March 1940, the Jumo 222A/B1 had breached the 2,000 horsepower barrier. April 1941 marked a significant milestone for the 222, successfully completing a rigorous 100-hour type test at 2,000 horsepower. This achievement led to an official production order from the RLM, setting the stage for mass production in Austria with ambitious output goals. Yet as the 288 evolved, so too did its demands, pushing the 222 to aim for even greater heights of 2,500 horsepower to compensate for the aircraft's increasing weight. This next chapter in the Jumo 222's development saw the birth of the A/B2 variant, with Junkers addressing both the power shortfall and the early model's mechanical issues. An increase in cylinder bore expanded the engine's displacement, and a shift to I-beam articulated connecting rods marked a refinement in its internal mechanics, illustrating the relentless push for aerial superiority in the face of ever-changing wartime requirements. In the quest for superior performance, the Jumo 222A/B2 underwent refinements that nudged its compression ratio upward and fine-tuned its valve diameters. A balance pipe introduced between intake manifolds of adjacent cylinder banks was a strategic addition aimed at enhancing the engine's operational harmony. To bolster reliability, engine speed was capped at 2,900 RPM, a measure that didn't hinder its ability to deliver impressive power outputs. At this optimized RPM, the engine was capable of reaching 2,500 horsepower for takeoff, maintaining nearly this peak performance even at the challenging altitude of 16,404 feet. The engine's performance across various power settings, climbing, cruising, and maximum, underscored its versatility and strength, essential qualities for the high-stakes demands of aerial warfare. The engine's fuel efficiency at cruise power reflected ongoing efforts to balance power with practicality. However, the journey of the 222A/B2 was not without its hurdles. Initial tests in mid-1941 showcased the engine's potential by briefly achieving 3,000 horsepower through overboosting. Yet this peak performance unveiled issues with harmonic resonance, alongside challenges with connecting rod bearings and internal component corrosion, obstacles that underscored the relentless push for innovation against the backdrop of war. The Ju-288 V5's maiden flight in October 1941, powered by the 222A/B1, marked a significant milestone, unmarred by the engine's challenges. The aircraft's four-blade Junkers VS-7 propeller, complemented by an annular radiator, hinted at the potential of this engine-aircraft pairing to redefine bomber capabilities. Despite these advancements, though, a shift in manufacturing focus in late 1941, coupled with the RLM's decision to cancel the 222 for the Ju-288 due to various issues and operational readiness concerns, redirected Junkers' energies towards the development of the Jumo-213 inverted V12. However, this pivot did not signify the end for the Jumo-222. It continued to be a subject of development, albeit with less priority. To combat the challenges faced by its predecessors, the Jumo-222A/B3 was developed with significant enhancements, focusing particularly on mitigating vibration and harmonic issues. An improved supercharger was a key upgrade, enabling the engine to sustain its power output at higher altitudes, up to 20,000 feet. Alongside this, a revised gear train and other reliability-focused revisions were incorporated, marking a comprehensive effort to refine the engine's design. With these improvements, the A/B3 variant showcased impressive performance metrics, achieving maximum power of 2,500 horsepower at 3,000 RPM for takeoff and maintaining substantial power at altitudes up to 9,000 feet. The engine demonstrated robust climbing power at lower RPMs across a range of altitudes, alongside notable cruising power efficiency. Its fuel consumption rates reflected the balance between power output and efficiency that the engineers aimed for. Despite successfully completing durability tests, the Jumo-222A/B3 never saw full-scale production. Its testing in the FW-191 V6 in late 1942 marked one of its few applications. However, the cancellation of the Bomber B program in mid-1943, driven by resource constraints and a strategic shift towards fighter aircraft, curtailed further development. The quest for altitude and power continued with the Jumo-222C/D, tailored for high-altitude operations with a design capable of delivering between 2,500 and 3,000 horsepower. This variant featured an increased bore and stroke, leading to a higher displacement and the ability to maintain power at extreme altitudes. First run in 1942, the C/D variant, however, was also sidelined due to the war's evolving priorities and conditions. The Junkers Jumo 222E/F engines represented the apex of innovation in their time, equipped with a sophisticated two-stage, two-speed supercharger that combined mechanical drive with an auxiliary stage powered by an infinitely variable fluid coupling. This configuration was complemented by an air-to-water aftercooler for each intake pipe, ensuring optimal temperature control and engine performance across a wide range of altitudes. Further enhancing this engine's capabilities were sodium-cooled intake valves and a compression ratio of 6.75 to 1. Features that underscored the engine's advanced design aimed at maximizing power and efficiency. The E/F's performance metrics were impressive, with maximum power reaching 2,500 horsepower at takeoff and maintaining substantial power even at high altitudes. The engine's climbing and cruising powers at various altitudes demonstrated its versatility and reliability, essential for the demanding conditions of aerial warfare. Fuel efficiency was a key consideration in the engine's design, with consumption rates optimized for prolonged operations. The incorporation of GM1 nitrous oxide injection and MW50 injection further boosted the engine's performance, showcasing the potential for significant power enhancements when needed. Despite its initial prioritization and promising capabilities demonstrated in flights with the Ju-288 V9 and tests in a Ju-52, the Jumo 222E/F's journey was curtailed by the shift in focus to the emergency fighter program in mid-1944. The Heinkel HE-219 V16, which utilized this engine, showed the potential for remarkable speed, yet the project saw limited flights before being abandoned. By the war's end, only a handful of 222E/F engines were completed. The development of the 222G/H variant introduced a turbocharger and intercoolers, pushing the boundaries of engine technology even further. This variant aimed to produce even greater power at high altitudes, operating at 3,200 RPM to deliver formidable takeoff and operational performance. In the latter stages of its development, the 222 showcased its high-altitude capabilities, achieving 1,970 horsepower at an impressive altitude of 41,000 feet. This highlighted the engine's potential in powering aircraft for high-altitude missions. A 222B2 engine, repurposed for testing the JH variant, underwent 22 test runs demonstrating the ongoing efforts to refine and enhance the engine's performance. Despite these tests, the engine was never installed in any aircraft for in-flight evaluation, a missed opportunity to fully assess its operational capabilities. The Automator Works suffered heavily from an Allied bombing raid on the 28th of April 1944, which necessitated the relocation of the 222 program to Oberrussel, near Frankfurt, a move that significantly disrupted ongoing tests and developmental work. Throughout its development, the 222 was tested in approximately 11 aircraft, showcasing its versatility across different airframes, including testbeds and prototypes. However, plans to integrate the engine into additional aircraft such as the Heinkel HE-219B and C and the Hutter Hu-211 were thwarted by the engine's readiness and external factors like Allied bombing raids. Speculation around the 222's potential integration into a four-engine Heinkel HE-177 highlighted the ambitious plans for this engine, although these did not come to fruition, with evidence pointing towards the use of the Daimler-Benz DB603 engines instead. Despite the broad interest in utilizing the 222 across various aircraft designs, many of these plans remained unrealized. The production of 289 222 engines stands as a testament to the effort and resources invested in this program. Additionally, the conceptualization of the 225, a 36-cylinder behemoth, underscored the ambitious scope of Junkers' engine development efforts, even though it never advanced beyond the drawing board. The backdrop to the 222's development was a complex interplay of technological challenges, strategic resource management, and internal politics with the Luftwaffe. Heinrich Koppenberg's significant influence over both aircraft and engine production at Junkers raised concerns about potential monopolies in aircraft production. Erhard Milch's tenure overseeing Luftwaffe programs was marked by a complex interplay of ambition, rivalry, and shifting allegiances. His concern over Junkers potentially monopolizing aircraft production under Koppenberg's leadership was profound. Milch feared that the success of the 288 powered by the ambitious 222 engine alongside other Junkers projects could corner large-scale production orders, sidelining other aviation companies from significant developmental opportunities. This led to suggestions that Milch may have intentionally altered project requirements to stymie Junkers' success, leveraging his position following Ernest Udet's death to influence Luftwaffe's strategic direction, often to the detriment of Junkers' efforts. The political and administrative hurdles culminated in April 1942 with Koppenberg's imprisonment, a dramatic turn of events rooted in Junkers' perceived failures to meet the RLM's demands. This period underscored the volatile intersection of political power plays and technological ambition within the Third Reich's aviation industry. In 1944, an intriguing chapter unfolded with negotiations between Japan and Germany, leading to an agreement for Japan to acquire production rights for the 222. This deal, valued at 10 million Reichsmarks, promised to include drawings, sample parts, and even Ferdinand Brandner's expertise. However, the arrangement was disrupted by Brandner's reassignment, leaving the transfer of knowledge and materials to Japan shrouded in uncertainty. The post-war fate of Ferdinand Brandner's capture by the Soviets and interned until 1953 highlights the continued value of his expertise, as he contributed to the Soviet aviation projects including the M222 engine, a reconstruction of the Jumo 222, and the development of the Kuznetsov NK-12 turboprop engine. Both the United States and Britain seized the 222 engines as war spoils, with the U.S. Army Air Force planning to test a 222E at Wright Field. Today, the legacy of the 222 is preserved at the Deutsches Museum in Munich, where the only known engine of its kind, likely returned to Germany in 1978, is displayed. So, we've journeyed through the saga of the Junkers Jumo 222, an engine that, in its heyday, promised to redefine the skies of World War II. Pitted against the backdrop of an era where engineering ambition flirted dangerously with the art of the possible, the Jumo 222 was a bold attempt to outpace the war's accelerating demands. Amidst a cauldron of competing interests, from Milch's strategic chess moves within the Luftwaffe to Koppenberg's quest for Junkers' supremacy, this engine became a pawn in a much larger game of power and influence. Yet, despite the political whirlwinds and the technical tempests it faced, the Jumo 222 left an indelible mark on the landscape of aviation technology. Its development was a testament to the era's relentless pursuit of innovation, a beacon of what could be achieved when human ingenuity was pushed to its limits, and it deserves to be remembered.